everyone. My name is Farhan. I'm a product design engineer. I've been an engineer for many years, and I worked at Apple and Google and many other places. This is Product Design Engineering Fundamentals. We're going to talk about manufacturing methods. This is the week 4 of our lecture course on product design. So how are things made? We're going to go through one by one different steps of different products and different things that we see around in our lives and talk about how they're made. Let's start with something simple. Ala Zaki, I'm going to hold up this can here. This is a can of cold brew, but you can imagine a Pepsi can or a Coke can. We talked about materials last time. Firstly, what material do you think it's made out of?
I feel like it's made out of mixed of aluminium and one other material maybe because of
Yeah,
its texture and the softness.
Yeah, so it is aluminum. It is definitely that. But then there's maybe a coating on top of paint or something, right? And there's actually a plastic kind of coating on the inside to protect it from rust, from the acidity. How do you think it's made though?
It could be stamped to make it like a sheet, and then you maybe convert it into a cylindrical form.
Yeah, great guess. I like that. So yeah, the actual what's happened. Well, we'll learn a bit more. Actually, we don't have this process today, but it is a process called deep drawing. You actually stamp out this big disc, and then you put the cylinder and you squeeze it. The reason why you don't make it a tube and then kind of bond it is you'll see that there's no seams, and the reason why it might be because the seams could have a failure point where liquid might have escaped or it might be not consistent, right? So anyways, we'll look at different ones today and chat about them. Cool. Let's start. First one, machining. This is a high-level classification, and we're going to go into a few different types of machining. But this one is a very important way of manufacturing things. It's cutting, and it's also you could also call it subtractive, where you have this block and you remove material to expose a final product, a final geometry. Okay, and so we have several pros and cons to this method. For example, it's very accurate. It's actually some of the best parts can come out of it, and it's what I like about it the most is it's very flexible. I can have a design today and swap it out and have another design tomorrow. That's because you have a tool that literally just cuts away parts and or material. Whereas the problem though is it is very expensive, and the reason why is because you have to program a computer to go and do that cut, and you have a lot of material waste because you're cutting a lot of that material away, and so on and so forth. Okay, let's take a look at a video on machining. You might have seen something like this before. We can see how there's this drill type of part that's spinning really fast, and it has this cutter tool on it. This is surface cutter. It's actually what it's trying to do is trying to make a really smooth end surface to start machining away at. Very parallel, very perpendicular at that. Cool. Zaki, you have a question?
Yeah. Does this cutter work for every metal or just for like a certain type of metal because of the strength?
Yeah, a very, very good question. There are different unique cutters for different materials for different things. For example, you can imagine cutting plastic is very easy, or wood is very easy, or in other words, they're soft. So remember the material property of hardness. The harder the material, the more difficult it is to cut it, because the cutter tool has to be harder than the material. So that's kind of the rule, one of the rules to think about. But there's also more things to think about: the speed of the cutter, how fast you're cutting it. So here in this case, it looks like it's an aluminum because it's cutting it very fast, and the cutter head is probably some sort of hardened steel. And then you can have other coatings like diamond coated, you can have carbide, you can have other things that make it really, really hard to resist breaking as it cuts. But it does wear out over time anyway. Sangeet, you had a question?
No, I mean, I had like a general comment about this one as well. Like how you mentioned that there's various materials that, like, with certain type of material you may not be able to cut another material, but so you find like sort of that, like, which material is stronger, you use the stronger material to cut the weaker material. And then there is different types like smoothing, cutting, and then there's like laser stuff these days.
Yeah. So in this particular one, yes, you usually cut with what the specific mechanical term is harder and softer. So you cut the softer material with the harder material. And then in terms of laser and other things, it's an interesting point. There are other those are other manufacturing processes like die cutting or laser cutting, and we'll look at those. But right now for this one, where you're spinning something very fast and like cutting away at it, it's machining specifically, right? Although you can have laser machining and stuff, but that's a little advanced. We won't talk about it. The other thing I want to talk about is there are different kinds of cutter heads. Right now you see there what's called a plane cutter, or it's trying to cut a plane off of the top surface of that material, make it very flat. You'll have other cutters that cut holes. You even have cutters that cut threads into the part so that you can screw on screws later whenever you want. Cool. So the next one we're going to talk about is stamping. Stamping is a process where you have the sheet. It's similar to what you're talking about, Zaki, at the beginning. It's a thin sheet that you're pressing into a form. And some common parts that are like this are like car body parts. You'll see it almost everywhere. It's a very, very common one, but I don't know why I'm blanking right now. But any kind of thin, flat, continuous thickness metal generally is stamped. And so some of the pros and cons are it's very accurate again, and it's very good for when you're trying to make a more mass-produced part, because you have this cutter that comes down and you can duplicate many, many pieces at the same time. But however, the problem is because you have this tool that comes in and cuts all these parts, it's expensive, right? Because you're making a custom tool for this thing, right? However, once you have that high initial cost, it becomes way cheaper to make every part, because you have this thing just repeating cut one at a time. So you have unlimited parts, or not unlimited, there's a limit, but essentially each part becomes basically the material cost. Okay. Was there a question there, Sangeet?
Not really a question. Like while you were thinking of examples, one of the examples that came to my mind was like license plates.
Yeah.
And
yeah.
something plate is that every plate has a different number. So the machine has to be designed in such a way that it stamps a different number. Like they can set which number to stamp, and it'll just stamp that different number on each, like different plates.
Yeah. So what will happen is you'll probably have the blank license plate that has no numbers on it, but maybe have like say the province or the state kind of embossed. You'll see that's called embossing, when you have like that shape kind of protruding out or in. That embossment and everything's probably done right away. And then when you have post-processing to actually have the numbers, what'll likely happen is they probably have something like, have you seen those printing presses where they have to manually put inside the different letters and then they print the books, right? That's kind of what this is, where they likely manually put the numbers and digits and then they press it in. And it's probably a manual tool because it's only like, it's unique to each one, right?
Or it could be something like, where have you seen those stamps which, we stamp on papers? They have like a dial on top that we can just like get different letters.
Yeah, yeah, exactly. Yeah, some versatile tool is what they use there, because so you have a highly lots, like you're manufacturing lots of them, lots of plates, so that's like mass produced, and then you have a custom tool for like the custom letters.
Yeah.
Cool. Awesome. Next we'll talk about we'll look at some stamping videos real quick. So it's very interesting. It's like literally you have this flat coupon, and then you have this press that comes in and presses with several thousands of tons of pressure, and it has like this positive negative kind of a tool, a nest, and they press it so it forms it into that shape. You see? Really cool. Next is die cutting. Die cutting is very similar. Maybe we should start with die cutting, but it's simply just have a cutter tool that comes and cuts it in, cuts that shape, and usually it's for like fabrics or kind of textiles, or you have paper and maybe plastics. For softer material generally, because you have a cutter that comes and cuts it. And usually you don't have like a 3D shape here, you just kind of cut and that's it. And the pro is you have many of them. You can have a lot of parts at the same time cut. It's very fast. You can have thousands done in a few minutes, right? But it's a little expensive to set up because you have to make that tool, but not very expensive because it's a simple tool. It's just a cutter. And the other con is you can't really do this with many materials. It's not super limited, but it's a little limited. And then the other con is it's for 2D objects. It's like a planar shape. right? And I think that's an important thing to remember, that this process specifically is if you want to repeat planar shapes for processing. But I'm looking around my desk and I can see that there are many planar shapes. So for example, let's just take a look at this Velcro here. That's likely die cut, so it's just the shape that they cut out of a big sheet of Velcro, right? Does that make sense? Even this whole bag is likely die cut. It's an open bag that they die cut into this shape. You see where the seam is, and then they later process it to sew it into place. Cool. Now we can take a look at a video of this. So this is a box die cut. Literally just put this paper in here and it cuts it into that shape. Very simple, right? Cool. Next, we're going to talk about CNC specifically. So we looked at machining, but let's talk about CNC machining. And CNC is computer numerical control. It's where you program a machine to cut material in a specific shape, and we change those tool heads and so on. And so from a CNC perspective, generally you can have complex parts and you can have complex shapes. However, the more complex your shape is, the more complex the CNC machine is. What you have initially is what's called a 3D CNC. You don't really call it that, or 3-axis. We have one cutter tool coming in one axis. It moves, for example, an X-axis and the Y-axis, and then it moves up in the Z-axis. So you can have this 3D shape in 3 axes. But say you have to curve the shape a little bit or move in a different axis, you need to start having a fancy machine where the part itself starts to move as well as the cutter. So you can get these complex shapes, and that's when you get to 4-axis, 5-axis CNC machines, and that's very complicated. Turbines are some examples. And actually, let's take a look at a video of a 5-axis CNC and you'll understand what I mean. So you see this complex bird sculpture shape. You see how both of them are moving to be able to curve and cut into those different intricate corners. You can never cut that into this in this like 3D version, because you're kind of cutting one layer at a time, right? Cool. Another very important machining process is called turning, and you use a lathe for that. And literally, you're turning the part very fast, and then you're coming in with a drill and cutting it. And it's mainly for cutting tube-like shapes or circular shapes or revolute shapes, which have a continuous or mostly continuous kind of circular cross-section throughout it, right? I forgot to add the pros and cons in this slide, but essentially, it's similar to CNCing, but essentially, the way that some of the pros are is that it's very precise. It's pretty fast, but it's usually for 1 or 2 parts at a time. And then other thing is it's pretty expensive, again, because you're kind of making one part at a time, essentially. So the time is usually what costs the most on these and programming it. Cool. I flew through a couple. Any questions right now? Cool. All right, moving on to the next one. Injection molding. This is one of the more advanced. Like, it's so common, but it's advanced, and because you have to really think about how to design a part for injection molding, and we're going to talk about that later in the future. But injection molding as a process is really, like, it's marvelous. It's designed really well, and it's complicated and interesting. And actually, there's a really good video on how injection molding works by the engineering guy. I'll send that as a reference later for you to watch. But one of the first things injection molded was actually a billiard ball. Usually they were made with ivory from tusks of elephants and other animals, and it was starting to get they're starting to get endangered, and so they were giving out a prize for who can create the best replica of that. And this I forget the man who invented it, created this injection tool where he created a molten, I forget what material exactly. It was some sort of a plastic resin that he melted and poured into the circular mold, and then that is basically what we have today, one version of that in injection molding. So how it works is basically you have pellets, like small pellets of a certain plastic. You heat that up to a certain temperature and you squeeze that into a mold that has that has that heart shape, and then you eject that with like some pins, and we'll see a video of that. Usually it's very, very repetitive, and its high precision is very easy to duplicate. You can have 5 or 6 parts of the same part in a tool, or you can have multiple parts in the same tool. So for example, what I mean by that is, let's just say we have this glass case. Let's just say this was made out of plastic, okay? you can have this one duplicated 6 times in one tool, and you inject that plastic and it takes up that shape, right? So all 6 of them. Or you can have the glass case, you can have maybe the AirPods case, right? 5 or 6 of them that all have the same material, and you can inject all of them. The main drawback is it's a very expensive tool, but the parts are very cheap afterwards. So yeah, let's take a look at a video of this. So it's that simple. So you have this positive, negative, and we can watch it again. Ooh, sorry. So you have this positive and negative kind of cavity and core, and you push that molten plastic in, and these pins come and inject it out when it's done, and then it does it again and again and again, and it's a few seconds that it does it. You see, it's very interesting. Cool. Next, let's talk about casting. It's similar, but for metals, and it's actually a very ancient technique. And it's literally you melt a metal very, very hot, and you pour it into a cast. And there's many versions of casting, like sand casting. This one I'm not sure exactly what it is, but like this image. But there's many ways to literally pour hot metal and into some vessel that takes the shape that you want at the end, right? And you use it a lot, surprisingly, especially for heavy machinery and big parts. And even sometimes you use it for mass production, where you might want to get a part to kind of close to final shape by casting it, and then you come and CNC it to finalize it. So for example, let's just say you have this bowl shaped 3D part that you want to make out of metal, right? If you CNC it, it's going to take forever. But let's just say you CNC it roughly to the right shape, and then you come and CNC you say you cast it to roughly the right shape, and then you come and post CNC it to make it more beautiful or like finished. That saves a lot of time and money because you waste less material because it's closer to the net shape, we call it, and you use the CNC to finish it, and it runs only for like half the time or quarter of the time. So yeah, then we can take a look at a quick video of this. This is becoming more and more popular on Facebook and YouTube and all these places to kind of see videos like this. It's becoming popular again to cast things. So you can see it. A little bit of liquid was poured in, and they cooled it down rapidly, and then you can see it takes up that shape, and this is an old school cast of some sort. And then usually you have this, what they call this part where the gate, which allows that fluid to flow in, and you saw him remove that from the video. So forging, you probably heard, you're forging forged steel or whatever. This is a process of basically applying a compressive load on a hot metal to shape it into a specific shape. And so you use it for knives, for example. You might have seen some videos there. You use it for large parts to kind of like get into to stretch it out, maybe to get it into a final net shape. And it's again very expensive to do, but it's used for very specific applications, like for example knife making. And you can see a video here of a tool that, or a way that is done before. So you heat up that metal very, very hot, and then here I believe they're trying to just narrow down this billet into maybe a narrower shape for some other application. But yeah. Cool. Awesome. Next is additive manufacturing. So one sec, this video is still playing. Okay, additive manufacturing. This is one of the more newer kind of manufacturing methods that we're looking at today. It's basically adding layer upon layer to create a final product layer by layer. And instead of removing parts like machining, you're adding material, right? So that's what's called additive. And since it's so new, it's still a little expensive to process things like this to use additive manufacturing, especially for like metals or like more high production parts, stronger parts for like production parts. And materials are not, I mean, today we actually have so many that it's really great. Like we have so many materials and so much stuff. There's so many ways to print with, but it's still a little tough to process it. It's, hobbyists or like me and you, might be able to use this, but like the everyday person can't just use a 3D printer. It's a little hard to use because it's, it breaks down and all that stuff. But in terms of the versatility and flexibility, today we have so many ways to 3D print things that it's becoming almost a secondary a primary way of building parts. What I love about it is that you have these intricate, very complex parts. However, one of the main problems is it takes so much time to print parts. So say you needed 1,000 parts done by tomorrow, either you buy 1,000 printers or you can't do it by tomorrow. You have to wait for 1,000 days, for instance, if that part takes 1 day to print. So yeah. There's a question, Sangeet.
I just want to show this is something that we printed, and it's like ADDITIVE.
Yeah.
And so this approximately took me 14 hours.
Yeah. And you probably don't even have it fully infilled, right? You probably have like 20%, so it's like not even solid plastic.
Hexagonal infill?
Yeah.
Like 20-30%.
Yeah. And so even that, like imagine you had 100% infill, that might have taken you like 30 hours or something.
And the thing is, the detailing, that's what made me surprised. Like every detail, like that.
Yeah.
That's makes me like intrigued about 3D printers.
Yeah.
Like to get that.
So what's interesting is that one itself is also not that accurate. Like that one's called FDM, fused material deposition, I believe.
Yeah.
But you'll see the layer lines. But if you look at SLS, for example, laser sintering, you literally have like 50 micron tolerance. You and me may not even perceive the layer lines, right? And so there's even better ones that are even higher definition that there's no way you can see it. I've used them before. And so it's crazy that you can have these amazing production parts. You can ship these parts sometimes with this process, and you can have it at home. You can have a liquid resin printer at home and it will be production ready.
Here at campus at UNB, we have a fabrication lab. Actually, Zaki works there. So he really 3D printers on the daily.
Yeah, there you go. So you can tell me more about it.
Yeah.
Have you guys seen this one? This is using SLS for steel. So this is what I mean, like for like future, like so imagine this one needed to be 3D machined, right? It would take forever to machine it to 5-axis CNC, very complex part. Even I don't even think it can be machined. We're looking at it now. So you can make these like impossible to machine parts out of 3D printed parts, or as a 3D printed part. There's very little waste as well. Like most of that powder just goes back in and you print it again.
Yeah.
So their wire EDMing is basically they're cutting it with an electrical charge wire to cut it off. And then I think they'll sinter this, which is basically baking at a very high temperature. Yeah. But very cool, very, very cool parts. Like this is an insanely difficult part. Like those holes, there's no way to machine that like that. Cool. All right. Moving on. Thermoforming. I don't have a video for this, but essentially really quickly, thermoforming is when you have like this plastic sheet that you suck into the shape of another part. So you kind of like duplicate a part by sucking that plastic part and heating it into a shape. So I should have given a video, but because there are many really great examples. Like for example, suitcases are generally made like that, or large plastic parts that need to take a big shell-like shape. MIM is the next one. I love this one. This is very interesting. It's not super new, but it's very cool. It's literally injection molding with metal injection molding. It's very expensive, but when you need to have highly intricate metal parts that cannot be machined and need to be mass produced, MIM is a great option. There aren't many options for a lot of different types of material options. Unfortunately, they're coming out with new ones every day, but standard is like a steel type. But you can have right now I've used aluminum injection molded parts, which is very interesting. It's different from cast or other things where you're not pouring it into a cavity. You're literally injecting the liquid pellets pressurized into cavity and core, and then that takes a shape and you do multiple of those. You see what I mean? So it's a little different than casting, but nonetheless very cool. And this is one of the more modern mass production techniques. All right. So yeah, actually here's a video of a MIB, and it doesn't show you how it works, but you'll see, if you look closely, you'll see that they look very similar to plastic injection molded parts. You'll see the gates, you'll see the parting lines, you'll see the ejector marks, and so on. So you can see how many thousands you can mass produce metal parts, which is pretty insane. Cool. So I didn't have details into these because you can keep on going. This is not even close to like all the processes that we can talk about. There's extrusion, blow molding, etc. Like there's so many, right? Laser cutting, you mentioned that, and Sangeet. So I didn't put that in here, but like even this is just some, like a few of the many. So it's up to you to research and learn a bit more. But I hope that in this lesson you had some exposure to many different types that you haven't seen, or at least thought about why they're used or how they're used. And as we go on, maybe on our 101s, we can talk more in depth of one or the other. And what's more important is why you choose one versus another. And let's talk about that now. So quickly, how do you select the right approach? Well, first is functionality. What is a part made for? So you need to, it's a harmonious kind of conversation. It's not like this is the manufacturing method I'm going to choose and this is going to be the part. It's not even this is the material I'm going to choose for the part. You need to think about the whole overall function for the product, and what is the right material for that function, what's the right process for that material, etc., etc. So there's many things. You might be like, I'm limited to only 3D printing. That means I have to use like some sort of PLA or ABS in this part, right? So consider that as well, the function. Next is the quantity. Yeah, so if you're making mass produced parts, if you're just making one off, it's very different. So here you can see the screws, they're actually screw formed, so they can be mass produced. But say you wanted to make one that has a specific screw shape that never existed before, you can do a CNC or something like that, which is fine. But if you need to make 1,000 or 1,000,000 of them, you might consider making a custom tool that can make that shape. You see, so you need to think about how many you're making as well. Cost, so that also ties into how many you're making. So if you have one part that needs to be absolutely perfect and it needs to function well, you might need to pay a high cost because you want to CNC it. But say you want to make 500 of them, if the part needs to be like beautiful, you might have only one option, which is CNC, right? And Apple like literally CNCs every single one of their iPhone housings. So they buy thousands of CNCs to let that happen, right? But let's just say you want to make a cheaper version of that, you might choose like a stamped part or something else, or maybe injection molded plastic, right? Or MIM. But the final quality of that part, the part quality, the cosmetics may not be as nice, right? So you have to think about that as well. Material availability, this is really important. For example, we use a lot of lithium in the batteries, or like cobalt in batteries, and maybe that'll be banned one day because it is a conflict mineral. So thinking about what material are available at what times, what's banned, what's not, what are the environmental regulations around it, thinking that through, especially as you go to mass production. And availability, sometimes you have some, say you're working with an Asian vendor and they might not have access to, say, MIM, or like one of the things we talked about is metal injection. Metal 3D printing is still fairly new, so you may not have access to many places that can do that. So that was a quick look at manufacturing methods. It was a really good discussion. I love this topic. It's really interesting. I'll share one extra bonus one for you. This is fabric, cotton, made into t-shirts, and that's a totally different world. The soft goods side of like leather making, PU, which is polyurethane leathers. This is cotton. There's like so many types of fabrics. Each one has a different processing method, and we're all wearing clothes. Like there's fabrics everywhere, and so it's a huge industry. There's a lot of manufacturing processes in there to make them. I wanted to open your eyes to one at least, to give you an idea. So you can see they have the raw cotton. They take the raw cotton and they pull it into a very fine thread. And then even after that, once they pull it to the fine thread, there are full out factories and machines that totally manufacture full clothing, and they loom large sheets of fabric.